Hi everyone, we're the portable drone recharging station team. I'm Harry, I've been in charge of some software design and also editing these videos.
Hi, I'm Tom, and I'm responsible for the charging part of the project.
Hi, I'm Will, and I'm managing the localization of the drone relative to the charging station.
In this project, we're developing autonomous retrieval, recharge and redeployment capabilities for an unmanned aerial system. The product will allow drones to operate for indefinite periods of time without the need for much human interaction. We modified an existing UAV to work with the ground station so that the UAV can be localized to the station, land and charge before taking off again and returning to the mission, without the need for a camera or anything attached to the drone.
And on the localization that can be performed without a camera, the drone is able to accurately localize itself relative to the ground charging station without using traditional methods such as the aforementioned camera, mapping, extended dead reckoning, computationally expensive algorithms, or similar unreliable wireless signal strength metrics like RSSI. You can do this through the use of ultra-wideband technology. This technology works by having a mobile beacon called a tag on the drone and a collection of beacons in known relative positions on the ground called anchors. This tag can then use a process called two-way ranging, whereby it sends and receives messages to the anchors and uses time of flight measurements of those messages to deduce range to each anchor. Then, using these individual ranges and known positions of the anchors, it can calculate the drone's position in 3D space through a process known as multilateration. This allows the drone to know exactly where to go and land at the charging station, all while being relatively inexpensive in regards to computation and power usage.
And for the charging part, for the wireless charging part, there are three main pieces to function the charging station. The first is power supply, the transmitter, and the receiver. For the power supply, when it's turned on, or actually the power start charging and it connect to the transmitter will start producing the charging signal and transmit them through the PCB charging coil, and which with the charging coil is already built inside the transmitter PCB board. Then the receiver, which contains a receiver coil inside the receiver board, will receive the charging signal and convert the charging signal into the charging voltage. And with a proper connection between the receiver and the battery will start receiving the charging voltage and start the charging process. And in order to make the charging system more robust, the resonance inductance coupling is also being introduced inside the receiver and the transmitter circuit board.
Retrieval, recharge and redeployment stations do already exist on the market, but they are all in certain ways not suited for military use. Most of these products use camera-based localization techniques for the landing sequence, which can fail in low light conditions and mean that only UAVs sporting a camera are compatible with the station. These products can also rely on charging methods that are not especially robust and can easily be obstructed if the station gets dirty. In a military context, this product needs to be able to operate in any environment. So it is ideal that it can operate in difficult conditions, like when it is dirty or in low light.
For the innovation, as I mentioned before, resonance inductive coupling is a relatively new technology which used for the charging kit, allows the power supply to take place over a large distance with a higher frequency. It is not yet a widely used technology, but will likely to be used we use it more in the future.
Further on the innovation, a real-time location system using ultra-wideband to localize the drone is more accurate and reliable in an established environment than alternatives, while also being more easily incorporated into a large variety of UASs, making the charging station not only more capable, but more adaptable as well.